In this problem, determine the electric field strength vector if potential depends on xy coordinates as these two functions. Okay, first we will, and this A is a constant, draw the approximate shape of the fields using the lines of force. Okay, so how to draw the shape of the fields using the lines of force? So what is a line of force? A line of force is the imaginary line tangent to it at a point shows direction of E vector at that point, right? The electric field vector direction at that point. So basic way of finding out these lines of force is like this. Suppose the field is in the xy plane. Okay, now suppose this is a line of force, directed here. So that means at this point the field vector is this way. This is E, that means this is Ex, this is Ey, and this is theta. Okay, so tan of theta equal to dy by dx equal to, it should be equal to Ey by Ex. So this is the, by this equation you get the family of the curves, these lines of force. It's not only a single line, it's a family of lines. Okay, so this is the way to find it out, by the slope. Okay, so let's look at this. This first one, phi is the potential. Phi is equal to A into x square minus y square. Okay, so part A, phi is equal to A times x square minus y square. Okay, you know Ex equal to minus del phi by del x, so that is equal to minus 2ax. Similarly, Ey is equal to minus del phi del y, therefore Ey equal to minus 2ay. So now in a fresh page we will find out. First I'll write it down, put it down again. We have got Ex equal to minus 2ax and Ey equal to minus 2ay, right? Let's see what was asked in the problem. Part A. Okay, so this is the E vector, you can write the E vector like this, equal to minus 2ax I cap minus 2ay j cap. Okay, and now our job is to show the lines of force. Okay, to show the lines of force, you know, by the slope. Okay, so dy by dx equal to Ey by Ex, so that is minus 2ay divided by minus 2ax, so that's y by x. Okay, so that's why you get dx by x, you get a minus sign here, right? Oh, that's x square minus y square. So here you get a plus sign, Ey is plus 2ay, right? Ey is plus 2ay, here also Ey is plus 2ay. Okay, so here you have a plus, so this becomes minus y by x. So dx by x plus ty by y is equal to 0. Now if you integrate this then you get a constant here, right, c. So integrating this you get a constant c, so that is log of xy is constant. That means x into y is a constant. X into y is a constant. Now it's a family of lines, you know, so the constant may have various values. So now I'll draw the curve. Okay, xy, you know this is the curve for rectangular hyperbola. So it's like this, maybe like this, depending on the constant, maybe like this or maybe like this also. Okay, now how to, now in a line of force you have to give the direction. So this one, whether it is down or up, you get it like this. See, ea, if a is positive, a is positive, then ex is negative here in this, say in the first quadrant, ex is negative and ey is positive. So this is the direction of field E. So here you have this arrow and the rest of the sides here. So x is negative and y is negative, so ey is there. So there it is. These are the directions, and here x is negative, so this field is positive here ex, and y is positive, so it's upward. So this is the direction of the field, you get this arrow, and here the direction is like this. Okay. So this is the solution to part A. Okay. Now part B. Part B, what was the expression? Phi equal to AXY. Here A is also a positive constant. Okay. So let's write that phi equal to AXY. I'll keep it here. So phi potential is equal to AXY. So therefore Ex equal to minus del phi del x, that's equal to minus AY minus AY. Similarly EY equal to minus AX, right? EY is equal to minus AX. So the field vector you can write E is equal to minus AY I cap minus AX j cap. Okay. Now for the line of force dy dx, slope of the tangent is Ey pi Ex, that's minus Ax by minus Ay, so that's x by y, implies y dy minus x dx is equal to 0. If you integrate this, you get y square minus x square equal to c, constant. Now this is the equation of a hyperbola, and depending on the constant, if you revise some more maths for this, if you have forgotten this, so these will be the hyperbolas. It may be on this side also, depending on the constant c, and this direction you can judge by that method we have used in part A. Say here, if you take in the first quadrant, where has that gone? Ex. Okay, y is positive, so Ex is negative, and x is positive, Ey is negative. Okay, so there it is. There it is. Acha. And let's look at this here. Here x is negative, so Ey is positive here, right? And y is positive means Ex is negative. Okay. So these are the arrows, and the rest you try out yourself.